All right, everybody. How is it going out there? Welcome for the next stream for Global Hack Week. Let me see if I can get some music going. Yeah, just a little background music. Yeah, I hope that you all are enjoying the week so far. It's been a little while since we had our previous stream. Actually, it hasn't really. It's only been a few hours, maybe about 12 hours. But yeah, I hope that you all were able to join for UT's stream. I know that UT's stream was not so long ago. So yeah, hopefully that was really enjoyable. And Alina coming with Global Hack Week Day 2 stream. Um, Hopefully you got some great insights into what was happening today. Actually, I have 3 back-to-back streams today. It's going to be this one, and then we're going to do a Wikipedia race on Discord. And then we'll have our BSA part 2, which is really going to be diving a little bit more into advanced concepts. Hi there, Joro. How are you doing? I hope that you're having a good time. Is this your first stream, or have you been to a few of the other Global Hack Week streams? Let me know. I'm always curious to hear from you all. But yeah, let's go ahead and get started soon. So first, what I'm actually going to do is throw up these slides. Let me just quickly put them up. Oh, we did attend one before. Awesome. And but we do have someone who's their first stream, EvoTech22. So hi, welcome for your first stream. And I see Adele from last stream. So hi there. I'm Shrey and Claw for Life. So hi everybody. Good to see we have a great crowd starting off the day. And now I need to pull up my VS code. If you don't have your VS code, let me just give a link to that, because it's really, really helpful to have some kind of code editor open. And here's just one that you can download for free. That's a really leading one, industry leading one. But of course, there's many you can use. Google Colab is another great place to find code editor. But yeah, and now I want to give you all a chance to check in. So just putting that link out as well so that you all have it. Remember, checking in lets us know whether you're interested in our events. It lets you also get some points for the end when we do swag drops and things like that. So definitely check in, super worth it. And here's our slides for the day. I'll just put that link up on the slide. But yeah, so before we get any further, I actually want to introduce myself a little bit. So we'll get started with that. But my name is Steven. I work with Major League Hacking as a coach at our events, our hackathons. I also help out with the fellowship program. So last time, if you missed the stream, we did have a stream about the fellowship. The fellowship is a program where you can work on an open source project and actually get paid a stipend to support you for that, and get some mentorship too from our full-time partners at places like Meta, Google Research. And so it's a great opportunity. And I work with the admissions team for that. And I also happen to do some streams from time to time for Global Hack Week. So this week I'm actually doing quite a few. So it should be great to see all of you familiar faces as we walk through these streams. And yeah, it says I've been working with hackers for 6 years. That's not a typo. I have ever since Actually, I've been since 2017, so it should actually say 7 years. Yeah, and we're almost to the end of 2024, if you all can believe it. It's kind of amazing to me. But yeah, so why don't we go ahead and get started with our goals for the day? And I actually want to dive into some of these concepts, which you all might think you know about, but there might be more to the story than you know. So, for example, with strings, a lot of you probably are familiar with strings, at least in the abstract. When you were first learning about coding, you probably did some strings. But there's maybe more to it than you realize. And arrays are the same way. Okay. And then these are some other concepts: linked lists, stacks and queues, and hash tables that you may know actually, or you may have never encountered because some of them are a little bit more advanced data structure concepts. So, yeah, definitely check those out. Oh, Abhinav says hello. I guess maybe it's to me. I'm not sure, but hi there. Good to see you. And no Tramish. Oh, let's see. Um, yes. All right. So why don't we go ahead and begin the next part here? And so the importance of data structures. We have a few bullets. So they're definitely the building blocks of efficient algorithms. And they allow us to store and organize data effectively. And they're crucial for optimizing code performance. And they're a super common topic in technical interviews. So, for all of these reasons, it's super important to study the data structures, even if you are not using them all in your day to day work. Okay, so now we'll talk about arrays, which are a collection of elements that we store in contiguous memory locations. And so, does anybody know what contiguous would mean? Um, I'll give you a minute to think about that. Contiguous. Yeah, yeah. So some good answers here. Sequential or continuous. Yeah, and continuous, uninterrupted. Um, and so, yeah, it's going to be a situation where one element comes after the other. Yeah, Goro has a great way of putting it. One element after the other. It's different than some other objects. For example, like a dictionary. There might be in a dictionary a way to store a new key value pair. If you're not familiar with those, don't worry, we're going to get to them. But it's not necessarily coming one after the other. You could add a new one all the time and access them in no particular order. And it does mean that each element can be efficiently accessed by its index. So, what I mean by that is you can use one number, the index, to grab the data stored at a particular element in the array. And they're typically fixed size. So, it means that you might have an array of 10, for example, and you could not, for example, add a new element to that array of 10. Now, in Python, actually, the native object of a list you can add to. You can use the .append feature, but it's a little bit different than a real array, where you would typically define the size of the array at the beginning. It's a homogeneous data type. So this is, again, a little bit different than a list. It means that all of the elements in the array are going to be the exact same type. And so you're going to have a situation where maybe all of the elements are integers, or all of them are floats, all of them are strings, but you would never have a case where one is a string and one is a number. Okay. And with a list in Python, you totally could, but with an array, no. So then finally, I want to say that for most languages, you will use something called zero-based indexing, which means that the first element in the array, you call that using an index of 0. Now, there are some languages, like R, for example, which are one-based indexing, but they're pretty rare. So you will mostly see 0. But yeah, great to see 45, like Arva said, on. Right. By the way, welcome to all of you, and I hope you all stick around for some of this workshop. And we're going to do some live coding, so it's not all just going to be me talking, but I do want to give you all some context before we get into that coding and those coding problems. Because a lot of people think they know what these are, like for array, for example. But when they dive into some of these concepts, they go, oh, I never knew that about array. So it's great to get more foundation. Anyway, array operations, we have traversal. So this is where we would, when we say to traverse an array, it means we go bit by bit in the array, element by element, and we're accessing those elements. We could use them to perform more operations or modify them even, but traversal allows us to go through and loop through those. Insertion is another operation that we can do where we add an element at a specific index. So it doesn't require us to actually go through all of the indexes to get to the fifth one and change it. We could say, all right, let's add a new element, let's say 5, add the number 5 at the third index, and it will immediately access that third index and write the 5 in there. We have deletion, which is going to be removing an element from a specific index. So you could just delete that value. And updating, which is where we change the element of at a specific index. So those are the basic operations. And Ayushman says, could you code only in Python? For now, I'm going to be using Python. Yes, so we're going to do all of our coding in Python just to get some basic universal language. But you could, of course, try these examples in any language. So there's these same data types in most languages. But yeah, does anybody have any questions about this array operations? I think maybe it'll be easier if we can see an example. So here's an example of an array of integers. So it has a fixed size, which is going to be 5. The size is 5 integers, and they're listed out there. This is the way you define it in Python. You just use array equals and then put it there. Actually, remember, this is a list, so it's a little bit different than a traditional array, but same way to access the third element. You just do array 2. All right? So array 2 would give us that 7. And Beast says, seems the main difference between languages is the syntax. I totally agree with you there. So it's mostly about syntax. And yeah, hey there, Twister Boot. Good to see you. Welcome on. But okay, now we're going to do some live coding. And here is where we're going to switch to our code editor to see some arrays in action and actually work with these. So I'm going to open up my code editor as a separate share screen. And I think you all can see that. Maybe I'll even make it a little bit bigger. But that might be the biggest I can make it, actually. But yeah, we're all going to try some problems together. So I'm just going to get this all set up. And first thing we're going to do is array declaration. So I'm just going to write a comment here so that you can all check the comments out. And we're going to do array equals. And Copilot wants me to make a really simple array, 1, 2, 3, 4, 5. I'm actually going to make the array from our example, which is 3, 5, 7, 9, 11. Okay. 5-element array. And if we print it out, we'll just say the original array, and we'll print out that array variable, and you can see we get it to the console here. So this is how we declare a new array in Python. And remember, declare, I don't know if all of you know what declaration means. Yes, this is VS Code, Akshat, but you can do whatever you'd like as far as the code editor. I put a link to how to download VS Code, but you can use whichever one you want. Same for coding in any language you want. And oh, that's a good question, a good point. So thank you for mentioning that. 7 is at array 2, because arrays start at index 0. For anyone who doesn't know, you get a fatal error if you try to go outside of an array. Let's try to do that right now, actually. So if we try to go outside this array, what index would we need to put in? Anybody know? Can anybody tell me in the chat? Oh, Abhinav says, what theme are you using? Good question. Let me tell you. Let's see. It is Dark Modern. I like Dark Modern a lot. The other one I like is Solarized Light, but people complain a lot about solar. Here, let me turn on Solarized Light and let me show you. People don't like this one that much. I personally like it, but they say it blinds them. I say, it's blinding. I hope I didn't just blind you guys. But let's turn it back to Dark Modern. But yeah, so yes, I'll ask again, just because people were mentioning to ask again, please. Basically, I was asking what index would we need to create that error that you were talking about, Beast, where we would go outside of the array. And we did get this 5. One yes. We even got a number 6. I actually think either one will work. So let's try 5. And you notice we get an index error. So the reason we get the index error thrown is because the list index is out of range. The range of possibilities is from 0 to 4. And funny enough, we can actually also pass a negative number. So if you pass -1, you can actually pass all the way up to -4. And when you use those negative numbers, it will, I guess you can actually pass up to -5. That's kind of cool. It will bring you in reverse order. But once you get out of range, yeah, it won't work anymore. The array 5 will do the same thing. Array 5 and 6 index error. So there you go. And yeah, -6, right? That did not work either. So, all right, let's move on to another aspect of this. So we can also do accessing elements, which is what we've been doing. And we did, yeah, we could do first element, which is array 0, second element, and so on. These negative numbers will give us the last element, second to last element, things like that. And we can do inserting an element at the end. So we can actually add a new one to the end. And this is what I was talking about with Python, which is a little bit different than other languages, where we can actually change the size of the array, because once we do this command, array.append13, if we run this top code again, where we just print the array, let's see what happens. Oops. We actually get 13 added to the list. And we can insert an element at a specific position. So a lot of people don't know about this, this one, but you can actually use the insert command. So insert 2, 6. Does anybody know what this will do off the top of their heads? What will the array look like when I print it out? Anybody want to guess? Yeah, so there you go. Now you know about that. And good job learning about the position insert method there. Yeah, so we're going to put a 2 at index 6. So when we run this, you can see it's actually looking exactly like Adele wrote. It inserts a new element at 2, at index 2, and shifts everything over. So it didn't replace the value at 2. If we did this, array 2 equals 14, and we did this, it actually replaces that 6. But if we use the insert command, it's going to add to the size of the array, which is a little bit different than many languages. But yes, Beast append is basically just Python's version of push. And we're going to talk more about push for those who don't understand what that is as a part of our data structures. But great observation. Python append is really just push. So let's keep going here. We have a few more to tackle. I wanted to talk about deleting an element. So you can delete elements by using the remove command. So if we click array.remove 9, and then we print after removing 9, and we just print the array, you can see it actually searches for that value and deletes it. So we grabbed that 9 and took it out of the array. So that's just another thing I wanted to show you all if you're not familiar with remove in Python. Good question, Akshat. Will it remove only one 9 or will it remove all of them? Honestly, let's try it. I want to try it now. Let's append 2 9s. Yeah, because I actually don't know the answer to that question. So we're just going to do it twice. So now we get this array. Oh, Red Robotics already tested it, but let's test it live. And it seems like it only removed one of them. So that is the answer to your question. It will only remove one of the 9s if you type delete. How do we remove 2? So, I think you might want to use a custom function to do that. Because, yeah, you could use a loop. Because you're going to need to access every element of the list to delete all of them. And this actually is something you want to think about with data structures, is the time complexity of your algorithm. So for the remove method, it's going to be relatively fast because it's possible that number 9 might not be at the end of the array. So it'll traverse the array and look for that 9. And if the 9 is at the beginning of the array, it'll just stop and remove that. But a loop that removes multiple 9s, it might have to go even further and check more of the array to get that second 9. So it'll be slower. And yeah, maybe there's a way to do it with the methods in Python, but the way I would do it is a loop that traverses the array. So yeah, it'll just remove the first one. Good point. So yeah, this is a little confusing. So let's just put another number in between. So now this is our array. And if we delete that, see, it removes that first one. So I just got rid of the 9 before I did that. And you can see we got that first 9 out, not the last one. So, okay, why don't we move on then? I want to get to some more topics. Well, actually, maybe we can implement this ourselves because it would be pretty easy to implement. Um, so let's make a remove all. Um, oh, this is such a neat way of doing it. So it just has a while loop, while the values in the array remove all, and it should just remove all the number 9. Keep going until it gets them all. Okay, so why don't we then go back because we've done a little bit of array declaration and array manipulation, but I want to keep moving on and talk about other data types. So the first data type I want to talk about or the next data type I want to talk about is strings. So you can think of a string as kind of similar to an array, but it would be an array of characters. So characters are a native primitive data type in Python. So it could be an A or a B or a capital C, things like that. And we can string them together into a string. There's several things you can do with strings. So concatenation is one of them. Concatenation just means to combine two strings. So when you make the classic hello world method, which is everybody's first program, um, part of it could be that you have one string that's hello and one string that's world, and you concatenate them together to make hello world. And then slicing is another one where you can subset a portion of the string and just only take that portion. Searching is another one where you can find a value in the string, and modification too. So you actually would need to create a new string to modify. It's not going to be the same as an array. So that's something to keep in mind as a slight difference between arrays and strings. All right. And I have a problem for you all to do. I want you to think about it in the chat. It's actually quite similar to what we did before, but I want you to solve it without using the native Python solution to reversing the string. So I want you to use concatenation, accessing elements, things like that to do this. And we'll give you a couple minutes to think about how you would reverse the string. All right? And we'll be back. All right, everybody. Hopefully you were able to think about this a little bit. I did see some comments in the chat about how to attempt this, and I want to get some ideas. So user Sandra said you directly use the reverse function. In fact, you can use the reverse function, um, but I did mention that I would prefer you to try this, doing it with some of the concepts like concatenation, splicing, Oh, can anybody else not hear me? Can anyone just give me a quick audio check? Because I do think the audio is good. Okay, so please check your speakers. So, like I said, please check your speakers, Evotech. And you can also use closed caption. I believe there's closed caption on YouTube. Um, but yeah, that's a good solution using the reverse function, which there is a string reverse function in Python. But I like this idea better by Rev Robotics to use substring. So we can substring, and substring is when we slice the string. So we're going to take the string and cut out a piece of it. And um, the idea here is a great one that Rev Robotics gave, and we're going to follow a similar one. Um, but I want to mention Daddle's one too. This is a good solution, but unfortunately, using this solution does not accomplish part of the problem, which is to reverse the string in place. So, in other words, we want to, reverse the string without creating a new variable. So, it's I think a little bit better to substring, but that's also a valid solution. Yeah, a lot of great answers here. A lot of you are coding in Java, I can see, which is cool. Um, so I like to see that. Um, but yeah, why don't we try to reverse this string in place? Strings are immutable in Python, though. Yes, but you can concatenate them. So we can actually accomplish this somewhat. So I have the solution. Uh, let's check this out. What we're going to do first, let me delete some of this stuff that we made for our arrays. We're going to make a function that we'll call reverse string, and we'll allow some argument here, s, which will be the string that we're interested in reversing. And sorry, just reading this. Where can I code the challenge problems? There is no URL to type and check the codes, but yeah, you can code and run locally. I think that's the best solution. So let me type the URL for you. There you are. But yeah, so when you have this function, we're going to first convert the string to a list to allow for modification, so that we can do this in place. As people said, it's going to be a little bit tricky to do this with just a string character. And I'm going to have two flags, so left and right. So I'm going to make left equal to 0, which is going to be the left side of the string. I'm going to make right equal to the length of the list minus 1. Okay. So this is, we're defining left and right pointers, we would call them, because they're pointing to the different sides of the string. And now I'm going to say while left is less than right, which means that the left pointer is going to be truly on the left of the right pointer, we're going to swap the characters. So we could swap them using this command that the code editor has suggested, where we just take s left and s right, and we set them equal to s right and s left. And this is how we're going to accomplish the in place part of the problem, because When we do this in place, we can really use an array, right? Because as folks mentioned, string is immutable. And then we will increment each of these. So we'll move left towards the middle and we'll move right towards the middle. And left needs to go up by 1 because it needs to ascend, and right needs to come down by 1 because it's starting at the end of the list and going down. All right, and then we will convert the list back to a string. So we can return basically we just join all of the elements, and that will give us. So let's run this. And when we now test the function, we can type reverse string hello, and we expect to see ole, and we get it. So that's great to see that we've actually reversed the string in place. Okay, so a lot of you had some great ones here, and they would all work perfectly well. So this is a great solution, MVK, and another one from Rev Robotics. This is kind of what I envisioned, your solution, Rev Robotics, which is a good one. And then Akshat has one too. And yeah, those will all work, although they will run into the fact that strings are immutable. By the way, if no one knows what immutable means, it just means that once you make a string, you cannot change its elements. And okay, let's check some other. Oh, and Twister Butte has a good one here. Although for this one, I would say you might want to be careful because you wrote j equals 4, which will work for this example. But if you notice in my code, I wrote length s minus 1. And the reason I did that is so that the function can work for any string. So let's use my code to do another example where we do reverse string, and I'll say the world is a great place. And it expects us to get that on the output, and we can get it. But if I use j equals 4 or right equals 4, the hello will work, but this one will not, right? See, it didn't really work. And someone said, can you scroll up back to the previous code? Yes, for sure. There it is. Sorry about that. Please take a screenshot also. If you need to take a screenshot, go ahead. Yeah. Also, thank you, Rev Robotics, for pasting that code in the chat. That's really useful. And Beast of the East says, Python doesn't have element plus plus? No. I kind of don't like that, actually, but it doesn't. And so you use plus equals 1. And No Tramish says, why not just use indexing? Yeah, I mean, we are sort of using indexing here in this line, but there is some possible alternatives. There are many ways to accomplish it once you put it into a list. But yeah, can you summarize the logic one more time? Of course. And actually, let me print out. I'll make printout statements to actually print out the values of these. So we're going to print out the string first. And we'll print out the list. Once it becomes a list, we'll print out the left pointer, the right pointer, and then I want to print out the characters themselves. So we'll print s left and s right. So we'll print left, right, s left, s right, and then we'll print afterwards the same thing. And then we'll print again right? And maybe we'll just print twice, please. Okay, so this is before moving the pointers, before the swap, let's say. And we'll call this after the swap. And so now when we print this, when we run this function, we can see how it works. So the string is hello. You can see that. The string as a list breaks the string up into these 5 characters, all right? And so now the advantage of this is we can access each of these and swap them in place. So the left pointer starts at 0, which, if you remember, accessing the list at element at index 0 will give us H, and at 4 will give us O. That's exactly what we see before the first swap. So we see 0 and 4 is H and O. And then after that first swap, we see that now the pointers are at 1 and 3, so they'll be at E and L. And that's exactly what we see. So then we swap E and L, and when we swap them, we get to L and L, which are going to be the same thing because it's the middle character. And actually, I want to print out, I would like to print out the list itself each time too. So let's do that as well. And so you can actually see how the list changes every time. So the first swap swaps O and H, the second swap swaps E and L, and the last swap doesn't do anything. Well, the last line doesn't do anything because both pointers are in the middle now. And once the pointers are the same, this inequality is no longer true, and we go to join them up. So I hope this gives a little bit of a better understanding of how this reversal of the string will work. But yeah, it really is about just swapping each of the elements and then moving further and further into the middle of the list. All right. So yeah, that's great that we can go through that. And there's another solution, actually. And you can use the Python-specific syntax where we do : -1. This is what we did in the Cracking the Technical Interview workshop from yesterday. But it's really very specific to Python. So if you want to try that, please feel free. I'm not going to demonstrate it because I did that yesterday, but yeah, and no problem. Thank you, Beast, for pointing that out. And actually, if anybody would like to know more about something or you want me to go over it again, we have plenty of time. There's no rush. And actually, we have 3 sections for this fundamentals of data structures. So there's plenty of time to go through it all. But I want to now move on, actually, and ask you a little bit about another form of data, computer data, which is called linked list. Okay, and a linked list consists of nodes. Now you might be asking, what's a node? A node contains data and a reference. And the reference is a pointer, which points to the next node. So that's why we call it a linked list, because we're essentially linking together all of these nodes using pointers. Yeah, Python is really cool. I love Python. It's very, to me, it's a lot more intuitive than some of the languages that many people start out with. Like, for example, many people will start out with Java because it is one of the most used languages even today, even with all the advancements. Java remains one of the most common languages. But yeah, Python is, I think, a lot simpler to learn, which is why I love to teach about Python. But yeah, the idea with linked list is that you have dynamic size. So it can really grow or shrink during a runtime. And you can insert and delete without shifting the elements. So this is something that we were actually exploring a little bit with the Python lists. Python lists are a lot more similar to a linked list, but they're not, because the efficient insertion deletion, I'll show you how it works. You can actually just alter the pointers around the elements. Yeah, Java is kind of annoying with all of its libraries and structure. What Java is good for is there's a lot of things that run on Java, and there are some programming platforms that require Java. So it can be really useful to know Java, but I do think that Python is better. Yeah, list in Python is a little more like an array, but they each have some elements of each other. Yeah, like for example, the dynamic size of linked list is similar to Python list, but it is more like an array, I would say. And so here's some types of linked lists. First, we have a singly linked list, and singly linked is really just what it sounds like. You have one node that points to the next one. And a doubly linked list is where nodes point to both the next and previous nodes. So you kind of are connected in either direction. And circular linked lists are where the last node points back to the first node. So there really is no node without a pointer. So those are just a few types of linked lists. And I actually have a visual demonstration here to show you all what a singly linked list looks like. And so the data is going to be the value that's stored in each node. So for this first node in the linked list, the data is A. And then next is a reference to the next node in the list. So node.next points us to B, which is the next data in the linked list. And then node.next.next points us to C. So now we have all three nodes and they're all linked up in a singly linked list. And if we wanted to delete an element, like let's say we wanted to delete B, it's actually not necessary to totally restructure the data set. If you remember, one of the advantages here is efficient insertions and deletions, because there's no need to shift everything over. Yeah, exactly. Linked lists are used for insertion and deletion because it works efficiently. So if you need to do this often, definitely look into linked lists, because look at this. All we did was delete element B, okay? And then altered the pointer or the reference in node A to refer to directly to C. All right, so we just moved the pointer to the C and we deleted B, and now the list is totally functioning again, which is great. We only had to do two things. We didn't have to shift over so many elements. And yeah, why don't we also see a live demonstration of this? So we're going to actually go into our code and do some live lists, linked lists. And I want to use some object-oriented programming for this. Okay, we're going to actually build some objects. I don't know how many of you are familiar with object-oriented programming. I think there's actually some of you who have done this because you have learned Java. So I'm hoping maybe for some of you, you've at least heard of object-oriented programming. But yes, that makes linked list main advantage loading speed for these operations. So if we're doing specifically deletion insertion, we can do that. Yeah, and Reclosaur says, yes, done them in my bachelor's, that's great. And objects are tough but fun. It's like IKEA on the computer. Yeah, true. I love, look, I was looking for a coffee table on IKEA, actually. Let me show you which one, but it's sold out. I wonder if it's in sale again. Oh, I can't find it actually, but it was a really cute coffee table, and I kept refreshing on the computer, but I never could get that. But Yeah, let's try and write this down a little bit, some of these objects. And the first object I'm going to make is a node. All right. So the node, remember, is the basic building block of the linked list. So when we define a new class called node, you can see we usually use a capital letter to make the name of the class because that's just a convention in most programming languages. But that node object is going to be our basic building block. And I'm going to define what they call a dunder method. So this is define a dunder method. Has anybody heard of a dunder method, and do you know why it's called a dunder method? So the reason we call it a dunder method is because it has double underscores. So double underscores you can see right here on the left and right. There are some other dunder methods, like there's a dunder method called string, REPR. So these are how the object would look if you cast it as a string, how the object will represent itself when you come it to the console. And they're sort of built into all of these classes by default, Dunder methods. But this init method is one of the most common ones, and it's probably the most common Dunder method. It typically accepts self and also some attributes, if you have any, that you want to assign to the node object. So here we're going to take self, which is the node object itself, and some data, and we can make some attribute of the node called data. And then self.next is the reference, remember, and we'll just set it to none for now when we first initialize this node, but we're going to change that when we make our linked list. So the dunder method is going to essentially called init. It initializes the node object. All right. And now we're going to make a class called linked list. And it already tells us how to do that, but I'm just going to go through it step by step. Yeah, and someone asked, how common is Python used for software engineering? The answer is very common. A lot of people use Python. In software engineering, it's a great language to learn for that purpose. Some other languages that are really common for software engineering are JavaScript, TypeScript, and Java, but it really does depend on the project you're working on. Yeah. And this is a good answer by Twisterboot about, I saw this question by Vista-Views. I'm wondering if linked lists are faster to iterate through than arrays or array lists. It's a great question. But I agree with Twisterboot here, because if you traverse an array or a linked list, you need to check all n elements. So if you're in a linked list or if you're in an array, you're still going to need to traverse the elements. So there's no real advantage to using a linked list if you're trying to traverse all of the elements. It really comes in those insertion and deletion cases. But that's a great question. And all right, let's go ahead and define our linked list now. So maybe by looking at these linked list examples, we'll see how that works in practice. But we're going to do another dunder method where we put some head on the linked list. And we'll have a method that appends a new node to the end of the linked list. So this is going to be, we'll just call it append. and it needs to take in self, which is the linked list itself, and some data that we might have. And the first thing it'll do is have some new node, which we will use our newly created object, node class, excuse me, which will take on this data. So let's say we were trying to create the B node. Okay, so the data would be B and new node would be that B node. And if the self.head is none, then we will put at the self.head attribute the new node. So head, remember, head will just be that very first node, all right, in the linked list. And that would just return. So when you return, it kind of exits you out of this whole process. But if that's not the case, if there's already a head, then we want to say last equals self.head. And while last.next, so this means while there is another node to linked to the current node, we will just update the value of last until we finally get to the end and there's no more next node. And then we say that next node is going to be our new node. So in this case, if the node was B, we would get to that first node A, which would be last, and then we would do last.next, and it would say there's no node after A. Okay, well then let's make that next node B. All right. And we can do a few more functions here. So one of them could be prepend a node at the beginning. And so for prepend, we're just going to have a new node, and we're going to put the new node.next equal to the self.head. And then we will do self.head equals new node. So what we're doing is we're saying that the new node becomes that very first node in the linked list. All right, let me comment a little bit of this actually. So this is, we create a new node here. What's happening here is we're setting the next, yes, so the next, and this would be the reference or pointer of the new node to the current head. So that, let's say A was is our original head. That's now going to be the next of our new head. And then of course we set the head of the linked list to this new node. So it's kind of like we're adding to the beginning. All right. Someone says, why are you coding in Java? Can we code in C++ or Python? I wasn't aware that I was coding in Java. I think this is still Python. Yep, it still runs in Python. Yeah, sorry. It might be a little confusing because class is also possible for Java, but actually we can do class in Python as well. Okay, and another question. Let's actually answer some questions because how easy will it be for me to adapt to algorithm and data structure? So we're going to actually do quite a bit of DSA practice over the next 3 sessions. And so you will hopefully just get some more exposure to these concepts as we go through. We're going to do lots of live coding and ask you to solve someone. So it'll be a great way. And actually, I have some resources too to show you. Yeah, this is great too, Twister Boot. You can practice on LeetCode, HackerRank, HackerEarth. There's tons of great places to find these fundamentals. But yeah, so let's keep going here with some of these because we're still building out our linked list. Um, I want to make a way to delete a node. So this is going to help us um, find a way to delete. Remember, I said that deleting a node is really important. So here's the way to delete a node. I actually kind of want to do it a little bit differently. So we take a self, which is the node itself, which is the linked list itself, excuse me, and we'll need a key. And the key is going to tell us which node we want to delete within the existing linked list. So, for example, our key could be C, which is the last one in our linked list. So first we need to store the head node, as they say in this example. Oops, I'm not sure what I just did. Store the head node. So we'll just say temp equals self.head. And that's because we need to know if the head node holds the key. So if the head node is the key, so if temp and temp data is equal to the key, then we want to do the following. So we'll say self.head equals temp.next, meaning that head of the linked list will now be the reference, so the second element in the linked list, and then we'll just say temp equals none. So we just destroy that previous node and return. But if it's not the first one, then we need to search for the key to be deleted and keep track of the previous node. Why do we need to keep track of the previous node? That's because we need to know where we're going to point to once this node is deleted. Because, yeah, if we just don't keep track of that, and if you remember in our slides, we need to make sure that we point back from A to C, connect them again, or else it's no longer a linked list. So we need to make sure that we store that previous one. But yeah. And let's go back to our code. So we need to, as we said, store the previous node. So we'll say previous, we'll start that out equal to none. And then here we say while temp and temp.data is not equal to the key. So that means that these nodes are not what we're looking for. We'll just update previous to be that temporary node that we're scanning through as we traverse this linked list. And then temp is now the next element in the linked list. So we're just going to scan through these nodes until we find the one where we are looking for. And if we don't find the key, we can just say, just exit out. But if we do, then we're going to unlink the node from the linked list. And the way we do that, so we assume we found the right one where temp equals the key that we're looking for. The way we do that is we're going to have to remove this temp. And so what we do is we type prev.next. So this is the previous node, its reference. We're going to set that equal to the temp.next. So this is where we're taking that A node, which is the previous node, and connecting it to the pointer of B, which is the C node. So this is like where we're going from A to C. And then we can just simply get rid of the temp node and set that equal to none. All right. And I'm going to make one last function because we could make insertion, but I want to actually insertion by key. It will be super similar to this, where we just have to save the pointers on either side and just connect them. But we'll just make a print method where we just start at the temp and we just print all of the temp.data and then move to the next one, print it again, and just keep going until we get to the end. But yeah, let's just try and make this work now. So I'm going to test the linked list, and we use list as our variable. And yeah, let's just append one, why not? And then we'll print the list. Oops. So if we print the list, then we get 1. Let's add some more into here. We'll add 1, 2, 3, so we get our list here. And we could even then prepend 0. Oops. So let's try prepending 0 and printing. So we can put 0 at the beginning, and we can even do a delete. So let's just do delete 2. Right. So now we're down to 0, 1, and 2. You can see it's quite fast and quite efficient. So here we're using our node class to represent each node, and we have this linked list class that we made, which manages these list operations. And we did a few like append, prepend, delete. And I would challenge you all, why don't you try to do insert? I would love to see that. Yeah, and some good advice here in the chat about how do linked lists work. Yeah, it does take a little more setup than an array. I mean, we can have some pre-built class. Actually, linked list is not typically a primitive data type in most languages. Array is. So that's why it's so much more convenient, because actually they've already built most of the infrastructure for array in Python. So linked list is a little bit more complex, but you can see we have easily written it up in a few minutes. And yeah, let me bring us back to the delete function where someone was asking about that. So I'll just leave that up. So if anyone wants to take a screenshot of that and try it on their own, they're welcome to. I have some comments here too to help you think about it. And some question, Adele says, why did we use temp equals none? Doesn't Python have some kind of garbage collector? Well, in the end of the singly linked list, we want to make sure that the last node, that its reference points to none. We don't want it to point to, a value. So yeah. Oh, I'll paste the code snippet. Good call on that. Yeah, Hershore says, can we get the code snippets? Yeah, I will share that with you. All right. I just made a little code share so that you all can see this linked list code. So go ahead and check that out if you're interested. Yeah, it's a great way to get it. You can also screenshot these and then use most of the computers these days will actually have object detection to grab the text out of the screenshot. But if you want to get that in an editable text form already, just use the code share link I sent. which would be a great way to do it. All right, and I'll keep sharing more of these code shares actually, because I think that'll be really useful to all of you. Let me actually I'll make a note of that for the next time we do that. Um, but yeah, I want to actually ask you all a little bit to do another problem. So remember we talked about circular lists um, a little bit, but I want to tell you about a concept called a cycle. So in a linked list, we can actually get what's called a cycle, where the node's next pointer points to a previous node. So it means that we're going to form a loop so that as the computer traverses the linked list, it just kind of goes around and around and around this loop. So I want to now use these codes to say, given in a linked list, determine if it has a cycle in it. So I want you all to think about this a little bit. Um, does anybody have an idea of how we might detect a cycle? Yeah, so a lot of great suggestions by the chat. We have Twister Boot saying fast and slow pointer, and adding a suggestion: the slow pointer in a cycle will be caught up by the fast pointer. That's a good point, because yeah, if they can catch each other, then there must be a cycle, right? Because if you think about it, you know, tortoise and hare style, if the hare is always faster than the tortoise, then it will just run away and they will never catch each other. But if they're in a circle and they're doing laps around a track, they will meet many times. So that would be a difference between, um, cycle and no cycle. So 2 pointers, great suggestion. And then Adele says maybe put a node in a dictionary while checking if it exists in the loop. That is actually another great idea. Using some kind of dictionary to keep track of what we've already seen. And so you could implement that one too. And then if it crashes, the program will have an implemented that too. That's, I suppose, a good idea. But then we have to run the computer for a really long time, huh, to check it. So maybe we can actually find a better way to do that. And then let's see, another one. If self.next plus one equals self.head, that's true. But let's think about this piece. So what if I gave you this following linked list? So here's a singly linked list. So if you had this singly linked list and you were on node 3, the self next will be 0. But and that's equal to the self head, to the head of the linked list. But is this a circular cycle? No, it's actually a singly linked list with no cycle. So as a twister, it will end up in the wrong result if duplicates are here. I am going to focus actually on the fast and slow pointer method. It's called tortoise and hare algorithm, which is exactly sort of what we were talking about. You make two pointers, so one is going to move one node at a time, and one is going to move two nodes at a time. And if there's a cycle, then these two pointers will eventually be equal. So they'll be the same exact position. They'll be in the same exact position, right? And we can check that, and there's no way to have two duplicates values that will be equal because we can check both the data and the, the reference and make sure that they match for that particular pointer. And B says, what if the fast pointer skips over the slow pointer? Wouldn't that be a problem in odd numbered lists? And that's a good question. So it is a problem in an odd numbered list. In an odd numbered list, the fast pointer will skip over the slow pointer. But it will then continue to cycle through. So an odd list, let's say we had an odd list 4, 5, 6. That's an odd list, right? But if we just keep cycling through, what is that list if we cycled through twice? If we cycle through twice, it's actually an even list. And an even list, they will meet. So at most, this algorithm will take a couple traversals to get there, but they will eventually meet, even if the list is odd. So that's a great question. And yeah, it would make an odd list twice as slow, but eventually it will get those to work. All right. For problem understanding, should it be fine that there's 2 zeros in the array? Yes, and the reason is because the basically what you have is 2 zeros, but they point to different nodes. So in order to check that your pointers have matched, they need to match both in both ways. So it should be no problem. And yes, I think actually, as Twister said, you may not even depending on how you do it. The way we've done it here, where you have slow pointer that moves one node at a time, fast pointer moves two nodes at a time. You could actually, I think, you could skip in certain cases. I'm not sure. I would have to really look at it to try and make a case where they skip to convince myself, but I'm pretty sure that it's possible for them to skip at least once. But then again, when you have odd number, you just double the length of the list, and now you have an even list again. But all right, I want you all to try this a little bit with me. We're gonna do some live coding, and we're gonna code this up together. All right. So we're going to use our code from the linked list class that we made and the node. We're going to keep all of that stuff. We can sort of get rid of some of this stuff. And because we're going to make a new function. And the function, we're going to call it has cycle. All right, and it's gonna tell if we have a cycle in our list, our linked list, and we're gonna ask it to give us the head of the list, so that we just start at the beginning, and we'll make two pointers. So the first one will be slow equals head. All right. The second one will be fast equals head. So they're starting out at the same place. Like, just like the tortoise and the hare both start out at the start line of the race. And while the fast and fast.next, so this is just gonna make it keep going for forever, essentially. until it breaks out, which we'll make a condition to do that. Slow equals slow dot next, so that's going to move the slow pointer by 1, and fast equals fast dot next dot next. So fast will actually move 2. And you might say, well, fast or fast dot next will always, one of them will always have a value. So how are we going to break out of this while loop? Well, we're going to break out if slow and fast are the same. And so remember, when we compare like this, when we do slow double equals fast, we're comparing the objects themselves to see if they're both equal. And for the objects themselves to be equal, they need to actually be the same node. They cannot have the same value, like 0, like we did for our duplicate. They need to have both the same value and the same pointers. That will indicate that we're at the exact same place with slow and fast. So that will return true. And if we get through all of these, and eventually and eventually fast and fast.next are none, so we get all the way to the end of the list, then we'll return false. Okay, so that would mean we traversed the whole entire linked list. We got to the end where it was none. There's no more point to point to, and we return false because there's no cycle in that case. Okay, so let's actually try this out. We're going to give it a go. We'll create a linked list first. So let's just make a new cell here. Cycle list. And we'll just make it a new linked list. And we'll append some numbers here. Thank you, Copilot, for giving me such an easy way to quickly append a bunch of nodes, 1, 2, 3, and 4. And we can print this out, actually, if we want to. You can just see what it looks like. And we can create a cycle manually. So we're going to create a cycle manually by doing this. So we say cycle list.head next. So we did 4 nexts. So that's actually 1, 2, 3, 4. So after 4, what comes? The heading. All right. So we just did a cycle. And if we try to print this, it's actually going to be crazy. You see, this will never actually end. It just keeps printing and printing and printing and printing everything. So let's just stop printing that. But we don't know, if I were to show somebody this print list command, they're not sure if it's just not a really, really big list, right? It could be. But with our has cycle function, they can tell. So let's actually run the has cycle function, and we're going to use the cycle list.head, and we're going to pass that as an argument to has cycle. And when we run it, it gives us true. So we know that because the 2 pointers met, the cycle worked. And so we did have one. So great work, everybody, with this. And I'm curious if you all could tell us, anybody who maybe is a little bit advanced here, what is the time complexity and what is the space complexity of this algorithm? Can anyone tell me? We have not covered time complexity and space complexity yet, but we will. So I'm just asking this for anybody who knows yet. I think it'll be a good way to transition to talking a little bit about complexity. We're not going to talk about complexity probably today. I think that'll be a topic that we cover in part 2. Yeah, so Adele says the correct answer. Time complexity is O(n) and space complexity is O(1). And so what that means is that the time complexity of this algorithm is equal to, in the worst case, the length of the list. So let's say you doubled the size of the list. That means that the time of the algorithm could double as well, in the worst case. And then the space complexity is O1. And the reason for that is because if you look at this function that we made, we're really not going to be needing to define so much new variables, new memory as the list grows. The only thing we need is a fast pointer and a slow pointer. So they're just two single variables. And yeah, they're not going to get larger as we increase the size of the list. Yeah, space complexity is more efficient here in this case. O1 is more efficient than ON. But yes, can I bug you to go to cycle list again? Absolutely. And actually, I'm going to add this to the code share. So if you have the code share already in your, here's the code share. Let me add that to it. I think I can. Yeah, I'm just going to add them down below. So here's our has cycle function. I just added it. And here's our cycle list stuff. So now this all should be in the code share for you to see. But, yeah. All right, everybody, let's keep going then. I want to talk to you a little bit about stacks and queues, which is another type of data structure. And stacks are linear data structures that operate on the last in, first out principle, okay? And so what this means is that you essentially have a case where it's like a stack of books. So in the case of a stack of books, you can add and remove books from the top. But if you had a really big stack of books, could you easily remove the bottom book? No, it'd be kind of hard. Or like the middle book, for example, you probably would need a bunch of people to help you stabilize the book stack. It's basically only possible to remove the book from the top of the book stack. And in order to get to one of those bottom books, you kind of take off the top ones first and then grab it. So that's the analogy I have for stacks. And yeah, here's some common operations you can do with stacks. This is why I was saying that push is similar to append in a Python list. And in fact, some of these commands like pop, you can do for a list, or maybe an array, a NumPy array in Python. So, which is very similar. So push, and then you give an item that adds the item to the top of the stack, just like append added a number to the end of our list. And pop is going to remove and return that top item in the stack. And peek is going to check this top item without removing it. And then is empty is another really common operation that you can just check if that stack is empty or not, which is pretty straightforward. But yeah, these are just some of the common operations that you might see. And you might ask, why is a stack useful? And this could be for function call management. So maybe you have to call a stack, expression evaluation, and syntax parsing, and also backtracking algorithms. So maybe you have some maze solving thing where you want to backtrack and see, what steps you took just, in order. You could use a stack for that too. So it's all these really, these cases where you are just trying to really have a very linear way of tracing your steps. So here is a interactive problem. We're going to do another one. And this is given a string containing only these characters, comma, brace, and then and. Determine if the input string is valid. An input string is valid if open brackets are closed by the same type of brackets, and if open brackets are closed in the correct order. So if you look at these characters here, you have open and closed braces, curly braces, and hard braces. So here's some examples. First, we have this first string where you just do open and close. That's valid. And then here, the second string, we do open close of the normal parentheses, open close of the hard parentheses, open close of the curly braces. That's valid. But then we have some invalid examples. So this first invalid example is invalid because even though you have an open and a close, they're not the same type. So you have an open parenthesis and then closed hard brace. That's going to be invalid. And another one here, invalid, they're not closed in the correct order. So even though these are actually open and closed by the same type of brackets, they're not done so in the right order. You have to have them sequential. So we're going to try this one, try to solve this one together. And Adele says, I solved that one before, so awesome. So maybe if there's anyone in the chat who has a question, they can help you. And someone says, any resources of Unizon interview with OA recently? That's a good question for the chat. I personally don't, I'm sorry to say, have any resources about that. But maybe someone in the chat has some. There's always a lot of people in our community who are willing to help. So please chat out if you have the answer there. But basically what we're going to do here is use a stack. We're going to use a stack to keep track of the opening brackets. And when we encounter an opening bracket, we'll just push it onto the stack. And when we encounter a closing bracket, we're going to check to see if that stack is not empty. And if the top stack matches the corresponding opening bracket. So we're just going to basically pile onto the stack what we've been looking at so far and just check to see if they match and keep going like that until we reach the end of this one. So let's try to do this together. I'm going to open up my coding here, and let's just delete all this linked list stuff because we don't need it anymore. But we are still working in Python. So I'm going to make a new function called isValid parentheses. And we're going to make a stack. So I'm going to start this stack by using an empty Python list. And essentially, a Python list is a stack because remember, we were talking about how lists are a little bit different than arrays and a little bit different than linked list. Because for one, they're dynamic in their size, but you do sort of traverse them in order. Well, that's sort of like a stack. So, yes, what can I learn? I'm having trouble understanding the question, specifically that part. Yeah, no, those are not part of the comma and the word and are not part of it. So just consider these to be the valid characters, okay? I just put them all without any commas or ands. Those are the valid characters that are possible here, and they have to be matched up just like they are in this case. Hopefully that helps a little bit, but let me know if you need more clarification. It is a little bit of a strange question. But okay, so we're going to make a mapping now. And remember, we can use dictionaries in Python to make key value pairs. So I'm going to pair up all of these parentheses. So I'm going to pair up the closed parenthesis with the open parenthesis so that if we get to a closed parenthesis, we know that it should be corresponding to an open. And I'll pair up the curly braces. So a closed curly braces goes to an open, and a closed hard brace goes to the open hard brace. So The reason we do this is so that, when we see one of these in the wild, we can check to make sure that it corresponds to it properly. And then we can also do some loop, just like we've been doing in many of these, to traverse the string. So we're going to take each character in the string, and if the character is in the values of mapping, so that's all of these open braces, so open, parenthesis open, curly brace open, hard brace. If that's the case, then it's going to tell us that it's an opening bracket, or an opening brace, I guess I've been saying. And so we'll append that character to the stack. Now, it's also possible for the character to be in the keys. And if it's in the keys, then that means it's a closing brace, because these keys are these first elements in each of these rows. So in that case, we're going to say if, not stack or mapping character stack.pop. And what are we doing here? We're saying if the stack is empty, or I'm sorry, if the stack is full, present, or there's some character that's a closing brace would not be equal to the end of the stack, then we'll return false. Okay. And so what do we mean by false? That's going to make it invalid. Okay. So we're saying if the stack is essentially empty, or if the closing brace is not equal to what we would expect at the end, return false. And else, we could have an invalid character and return false. All right. And then if at the end we get an empty stack, we'll return not stack, which will be true. So essentially what we're doing is we're going to pop out the elements of the stack, check them against what we expect the closing brace to be. And if not stacked, then we'll just return those as false. And then in the end, we return not stack, which would be true, indicating that we got through the whole stack and we never saw this case. All right, so now we can do some of these. Let's check one of these examples. And we see, oh, it actually returned true. That's a little bit strange. Does anybody know maybe what I'm missing here? I must be missing something. I think maybe this might be on the wrong. Yeah, kind of hard sometimes to do these. Oh, there it is. Yeah, this was on the wrong tab. That's the thing with Python that you have to worry about, is if your tabs are correct. That's why I was getting a little confused, honestly. I was like, this is a little strange. But yes, so we have three possibilities here. The open brace, the closed brace, and it's neither one. All right, so let's try to add a little mix to this. Also true, but if we, let's say we added like this, that would be false, right? So you can see how it kind of works. And yeah, Akshat said, I've done this code on LeetCode. Yeah, a lot of these are sort of on LeetCode. A lot of these problems are super common ESA problems. And so we're just applying what we're learning to them. And yes, you pop in the if condition. So yeah, in this case, I guess we might mean over here. the idea is to check that if we do have one of these end braces, closing braces, we want to make sure that we're not at the end of the stack, and that we're also not going to be um, having this case where these are, you know, the same. So yeah, we want to make sure that these closing braces are going to correspond to an open brace, essentially. All right. So why don't we go ahead and try some more of this? We're going to uh, actually do a few, which is the last thing I think we'll talk about today, because we are coming a bit low on time. We'll save some of the last things I mentioned, which is the hash tables, actually. We'll save that for next time. We do have a part two coming up quite soon. But yeah, let's talk about queues. This is a little bit different than our stacks. Our stacks we're using last in, first out principle. And in the queues, we're using first in, first out principle. So we have a lot of common operations like enqueue, which is where you add an item to the end of the queue. We have dequeue, which is remove and return the item at the front of the queue. And then we have dot front, which is just returning the item at the front, but not necessarily removing it. And then dot is empty would check if the queue itself is empty. So these are some of the common queues. It's really quite similar to a stack. Um, but there are some queue use cases that are different than a stack. So basically, we have the case where the task scheduling and processing could be a great one because you want to do the first task that you assigned first, go in that order. Breadth first search algorithms could be a great use case. And then handling asynchronous data like buffers, where you are sort of reading in as you receive the data, you're sort of reading that into your client side. So these are all great queue use cases. And someone, what Kyler says, when you get a chance to explain this example, can you do an example if not stack or mapping character not equal to stack.pop? Yes. So just remember that stack.pop returns the top of the stack. So if the top of the stack is not going to be equal to this this open brace, it means that there's no open brace that corresponds to the closing brace. And the other alternative that we could have is just not stack, which means that the stack's essentially empty. And if the stack's empty, that's not good either because it means that we've actually have a closing brace at the beginning. So in either case, we would return false. So you can think of this as the first condition in the or statement is just making sure that the closing brace is not at the beginning. And the second condition is making sure that there is some kind of corresponding value there. And what's the logic of return not stack? It's because we want to just see if we were able to, once we peeled away all of the open closed pairs, we want to make sure that the stack is empty now. So yeah, we can just kind of eliminate those all and make sure that it's empty. And if it's not, then that would be making it true. All right, actually, let me paste this into the code share. I'm going to put the code share, I'm going to put it at the bottom, and I'm just going to put it on line 100 so that everybody can see that it's on line 100. And this is our stack code. And I'll put it in there. And you can all see. Adele says, when I solved it, I used to check the braces from the mapping and then popping in the elif body. That would work too. Yeah, that's a good solution too. And yeah, we're taking everything out of the stack to check them, like going through a box. Exactly. So the stack is letting us add, whenever we open a parenthesis, we want to make sure that there's some closing there too, before we take it away. And the stack is yeah, it's just letting us keep track of all of the parentheses that we've opened so far. Okay, so we're going to implement a queue, and we're actually going to implement it using two stacks. So we are going to build upon our stack knowledge, and we'll go back to the code together. I'm going to put it below the stacks code, and we're going to make a new class. We'll call it queue, and we'll make it first have some. Oh, this is a markdown cell. I was like, why isn't it giving me my nice color? We'll use a dunder method in it, and we will have self.stack1 and self.stack2. So these are our two. I actually like to call them in and out. And we're going to make an enqueue operation. So if you remember from our slides, enqueue is essentially when we're adding an item to the end of the queue. So we push elements onto stack in for enqueue. So let's make the enqueue function, and we need to give some item for us to add. And what we do is we push it onto the stack in. So we're going to append to that stack in Python list. And then we also can make a dequeue operation, which, if you remember from the slides, the dequeue is when we remove and return the item at the front of the queue. So if the stack out is empty, so we can just basically pop all the elements from stack in and push them onto stack out, which reverses the order. And then we can just pop them from stack out to get rid of the last one. So we're just going to take our stack one, our stack in, and we're going to slide them all onto stack two, stack out, and then we just pop off that last one. And that's going to remove the item at the front. Yeah, so let's try implementing that. So remember, first we need to do if not self.stackout. So essentially we're checking to make sure that that stack is empty. And while it is still true that there are elements in stack in, then we're going to just append them, push them onto stack out, and remove them from stack in by using pop. So we're just taking all of think if you have two piles of books and you're just taking one pile and you're taking the book off the top and putting it on the bottom pile. And then if self.stackout is not empty, which we will eventually have once we're done with all of these replacements, we can return the pop of stackout, which returns that last element and deletes it too, which is part of the dequeue function. And then else we'll just say that the queue might be empty. That'll take care of everything. Now remember, we wanted to make a function to check if queue is empty. So we can actually make an isEmpty function. And we return not self-stack in and not self-stack out. We want to make sure that both of these stacks are empty if we're going to say that the queue is empty. And let's see, what were some other functions that we did? Oh, that's right, we wanted to do front. So front just does the same thing that dequeue did, but without removing that first element. So let's try to implement front. And so essentially, we can just copy the code for DQ, but we'll call it front now. Oh, I didn't actually define DQ. Sorry, everybody. This was never actually defined, this function. Let's copy DQ again. So yeah, we'll rename this to front operation. And we'll call it front, the function. It also just needs self, just like DQ. And the portion of the first portion here does not really need to be changed. We're just going to switch it out. But then at the end, when we have our stack out and we're looking at the first element, we can just return that, or sorry, that last element. We can just return it. We don't have to do pop because pop will delete it as well. So we'll run that code. And let's test it out a little bit too. So we'll do q equals q. And we can do q and q, a couple of these. And then we'll just print q.dq. Let's try that. Should print out 1. Oh, it printed out none. I wonder if there might be some error here. Let's make sure that on the error, because we should actually be printing out 1. It actually went to this case here. So there might be something wrong with the DQ code. Oh, I know where the problem is. Again, with the tabs. I didn't really write that DQ function very well. Let's try again. Oh, still broken, funny enough. Oh, it's because I didn't return here. Yeah, we want to make sure that we return the pop, because that, and then we'll also get the same error if we try to use top, because that I just copied that from the DQ function. So let's try again, and we do get 1. So there's live coding for you, everybody. But let's try doing q, let's do another unq. We'll do 4, and we'll print q.dq. It should give us 2. And so that's just getting rid of the 2 from here, which is now the first element. And we can even try q.front. We don't need to pass anything to check the front, which is now 3. And we can do q is empty, and we should get false because we still have the 3 here. Now it's working. And yes, thank you, Adele, for helping me out with that. You did not define the method. Saying DQ while I'm holding off on lunch does stuff to me. Yeah, I know. Oh my goodness. Now you're making me think of DQ. I'm going to have to get some. It's actually really cold where I am right now. I'm in New York, and it's getting windy and cold, and yeah, definitely not a day for DQ. But all right, let me paste some of this code into the code share so that you all can see how we built the queue. So it's now going to be in the code share. I'll put a little example to get you started, but I'm not going to put all of the operations we did yet. Oh, great. East of the East, you're in Ontario. That is a lot colder than what I'm used to. So yeah, when you say it's good sweater weather, I might think that's really cold. That is a super nice place to be. I've been to Windsor, and also to Toronto. I'm not sure if Toronto would be considered Southern Ontario, but a great place. Okay, so that's going to be pretty much it for today. We're kind of running out low on time, so I'm not going to go to hash tables. We're going to save that lesson for part two, which we'll do later today. But for now, I want to give you all a chance to know what's coming next. What's coming next is actually our Wikipedia Races mini event. So Wikipedia Races mini event will be, here's how you check into it. It will be starting pretty soon, actually, in about 2 hours. And so I'm going to be running Wikipedia mini races on the mini events channel in Discord, so we'll have a chance to chat and learn about the Wikipedia mini event race. So yes, why don't we go ahead and end it there. I'll see you all soon. Thanks, Abhinav. Thanks everybody for joining. See you later. Oh, one question here. Where can I watch the recording? They'll all be on YouTube. So go to our YouTube channel, Major League Hacking, all one word, and you can find it there. All right.